Hello everyone, this is Teacher Harold, your junior high school mathematics teacher. And in this video, I will discuss about models real-life situations using quadratic functions. So at the end of this video, you should be able to relate quadratic functions to real-life situations, write quadratic functions in the form y equals ax squared plus bx plus c, and determine the values of a, b, and c from this equation. Grade 7 and 8 math deals mainly with linear functions, functions whose highest exponent of the variable is 1. This time, you will learn about quadratic function, how this function differs from that of linear function, and how this quadratic function be expressed in standard form are the main concerns of this material. When is a function quadratic? A function is said to be quadratic if it is a polynomial function of the second degree and can be expressed in the form y equals ax squared plus bx plus c, which is considered a standard form where the coefficients a, b, and c are real numbers, and a must not be equal to 0. Consider the following functions. We have 5, and these are the following. So let us try to find out whether each of the given equations is quadratic function or not. So you will notice that item numbers 1 and 2 are both quadratic functions since they are of the second degree functions. Of course, number 1 can be easily identified because of this quadratic term. So understood its quadratic function. But what about number 2? How do we know that this given equation is quadratic function? Okay, so in item number 2, now number 2 can also be easily identified as quadratic function because we can convert or we can transform this to standard form by multiplying the two binomial factors using what? FOIL method. And if we multiply these two using the FOIL method, you will notice that the obtained product would be x squared plus 2x minus 8. And this equation right here is the same as that equation given in number 2. So indeed, number 2 is just like number 1, a quadratic function. Now what about number 3? Number 3, the function is y equals 2x minus 10, which is obviously not a quadratic function but a linear function since it is a first degree function. So it's not. Number 4 has the highest degree of 3, so therefore this is not quadratic but a cubic function or a third degree function. Okay? So number 4 is again not a quadratic function. How about 5? Number 5 is not a quadratic function because if we simplify the right side, we will have this expression. Of course, use the FOIL method to obtain the product of these two binomial factors. That is x squared minus 9 minus x squared. So x squared minus x squared will give us 0, and what will remain on this side is negative 9. So the equation becomes y equals negative 9, which is obviously not a quadratic function. Okay, yun. Now we go to the next slide. What are some real-life situations that illustrate quadratic functions? Okay. Number 1, the path of the ball thrown into the air. So this is the illustration. Suppose you are playing basketball and you throw the ball to the basket, and you will notice that the path where the ball traveled into the air is quadratic in nature. Okay, so the drawing, the one that is being considered quadratic in nature, is the path of the path traveled by the ball into the air. Okay, so that is quadratic. What else? Number 2, the shape of a parabolic mirror or a reflecting telescope. This one, the shape of the parabolic mirror, this one. The umbrella-like shape is parabolic. And the reflecting telescope, this one. Okay. Next, number 3, the graph that maximizes the profit in any business. So it's parabolic. The graph shows the maximum profit of 12,500 pesos at a selling price of 35 pesos. So this is the drawing. So this is the graph, which is quadratic function in nature. Okay. Next, another one. The maximum area covered by the given amount of fencing materials. So this is the drawing. The area covered by the fencing material, probably the fencing material is somewhere around here, this one. And the area covered by this material is maximum. Next. Okay, this one. So if we trace the graph of the function, it's again parabolic. Okay. The U-shaped graph is quadratic in nature. Quadratic function in nature. Okay. Number 5. Okay, we have the next example of a situation that is quadratic function in nature. This one, the parabolic shape formed out of water fountains. Okay, so yung lumalabas mula sa tubo na to, na tubig, it forms a U-shape it creates a U-shape formation. So parabolic yung hugis niya, no? Ayan. The parabolic shape of water formed out of this one, yung fountain, no? Yun. Next. Now, why do you think these situations model a quadratic function? Remember from your grade 8 mathematics that certain real-life situations represent linear function. An example is based upon the relationship between the amount of water and time wasted when the rate of leak is considered at 1 gallon per hour. See the graph at the right. The graph results to a line, hence it is called linear function. This one, okay? The graph of the relationship between the amount of water and the time when rate of leak is a constant 1 gallon per hour. Yeah. Okay. The same thing is true with quadratic function. What common characteristics have you seen in each of the situations given above? Yes, all situations showed a certain U-shaped figure which is known in mathematics as parabola. Parabola is the graph of a quadratic function which will be discussed in the succeeding lessons. When you throw a ball at a certain velocity, we can find for its height. at any given time, which will produce a U-shaped figure as shown above when plotted. The same thing is true with water fountains, as a very familiar situation. Other situations modeled by quadratic functions are those that involve their maximum or minimum values. Finding the values of a, b, and c of quadratic function in the form y equals ax squared plus bx plus c. Refer to this table of examples. In this table, we have quadratic functions written in standard form, or y equals ax squared plus bx plus c, indicating the values of a, b, and c. Okay, so we have a table here. Under the first column are 5 equations that are all quadratic functions. And on the next 3 columns are for the values of the coefficients from each quadratic function. Okay. Now, for us to be able to identify the values of a, b, and c, it means that the given quadratic functions must be written in standard form. So let's begin for the first equation, which is y equals 2x squared minus 7x plus 4, which is a quadratic function in standard form. So we can easily get the a, b, and c values, and these are what? Okay, same thing with number 2, number 3, number 4, and the last one, number 5. Any of these 5 is quadratic function in standard form. So we go back to the first equation. We can easily identify the a, b, and c values, and these are what? 2, -7, and 4. In the second quadratic function, although the symbol used as a variable is small letter m, we could still identify the a, b, and c values because number 2 equation is also in standard form, and these are 3 for a, 8 for b, and for c we have -5. Same thing with the third equation. A is -7, b is -3, and c is -9. For the fourth equation, which is also in standard form, the leading coefficient is 1, b is 0 because the linear term is missing. Then the second term right here is actually the constant term, which is your c, -3. And for the last equation, the right side has only 2 terms and 1 term is missing, and that is the constant term. Therefore, the leading coefficient is 4, which is your a, and for the linear term, b is 1, and the constant term is 0. Okay, next. Example, rewrite each of the following quadratic functions into standard form and give the values of a, b, and c. And these are the equations. So we start with number 1. Okay, so what did we do with the first equation in number 1? First is we transform 2x to the other side, placing it between 6x squared and -9. Therefore, the left side now becomes 6x squared minus 2x minus 9. Okay, the expression on the left side has 3 terms which are in proper order. Quadratic term is written first, followed by the linear term and constant term. But then, this is not yet totally written in standard form, so we need to interchange the position of the right and the left side of the equation using the symmetric property, so that the equation becomes y equals 6x squared minus 2x minus 9. And from here, the equation is now in standard form. Therefore, a, b, and c values are what? 6, -2, and -9 respectively. Okay, now we go to number 2. This is the given. X squared is transposed to the left. Since that is quadratic term, it should be written first. So on the left side, we have negative x squared. Then 12 is the constant term, and this one is the linear term. So they must change position. After negative x squared, negative 5x should be the one written first. And the last term before the equal sign should be 12, then equal to y. Yun, yun, okay? Then interchanging the position of both sides. So y is equal to negative x squared minus 5x plus 12. And the a, b, and c values are this, negative 1, negative 5, and 12 respectively. Now for number 3, this is the given equation. So 7x squared transposed to the left, it's negative 7x squared. Then followed by 4x, and negative 3 should be written first after 4x, so that is plus 3, since on the other side it was negative 3. Going to the left, it will be positive 3, and what will remain on the right is just y. And then apply the symmetric property, interchanging the position of this side and this side. The equation in number 3 becomes y equals negative 7x squared plus 4x plus 3, which is now in standard form. Therefore, it follows that the values of a, b, and c are negative 7, 4, and 3 respectively. Now for number 4, transpose these two terms to the other side and arrange the three terms in proper order. Okay, the first term should be quadratic and the last term is constant term. And on this side, we only have y. And from this equation, interchanging the position of the left and right side by symmetric property, therefore the equation in number 4 becomes y equals 2x squared plus 6x minus 3, which is again, just like the three previous examples, is now in standard form. So the a, b, and c values are what? 2, 6, and negative 3 respectively. Okay? And for number 5, we just apply the FOIL method to get the product of these two binomial factors. Then combine similar terms at the middle. Okay, 10x plus x, it's 11x. You bring down the first and the last term. And this is the standard form, and the a, b, and c values are 2, 11, and 5. Okay? So that is how we transform quadratic equation to standard form and obtain a, b, and c values. Next. Okay, I think I'm done discussing this topic, and we'll see you next time.